of a certain bacteria is dp dt is equal to k square root of t, which we're going to change to t to the 1/2 power because we know full well that root's the root of all evil. The initial size of the population is 500. I wrote that up there. After 1 day, the population is now 600. Estimate the population in 7 days. All right, Mrs. V. What the doodles do we do here? I want to know the population. I have dp dt. What must I do? And find p by doing what? Antiderivative time. So I go p is going to equal k. That's a little unfortunate. T to the 3/2 over 3/2 plus, and I'm going to put p naught here. I'm going to use the other notation we're allowed to use. Okay. I'm going to clean this up a little because I don't like the way it's written right now. So 2/3 kt to the 3/2 plus p naught. Okay, so what do we do to find out what p naught is? We have to plug in one of our conditions, right? I give you 2 of them, which is kind of weird. Normally I just give you 1, but I give you 2. Which one do you want to plug in? 0 equals 500. 0 gives me 500, or 1 gives me 600. Okay, so we want to get 500, and we plug in 0. Oh, I didn't plug in 0. That's a detail. That make sense? Okay. So what does p naught become? 500, right? Crosses out, I get p naught equals 500, which is interesting because it doesn't solve my problem yet. I still got a stupid k in the problem. I've got p equals 2/3 kt to the 3/2 plus 500. That's unfortunate. How am I going to figure out what k is so I can figure out what it is in 7 days? I don't know. Well, what can we try to do? Yeah. Let's see. One for t gives 600. Let's see if that works, right? It got us the p naught. Maybe it can get us a k if I plug in the other one. Okay. So I'm going to put a 600 in here. I should get 600 when my t is equal to 1. Do a little mathage. So now my new equation is going to be p equals 2/3 of 150 times t to the 3/2 plus 500, right? Well, 2/3 of 150, that's 300 over 3. That's just 100, right? So now how do I figure out what it's going to be in 7 days? Plug it in, yeah, plug 7 into 3/2 and call it a day. That's the curve. So if I might calculator. Remember, if you're going to use 7/3 as your variable, as your exponent, make sure you put parentheses around it, okay? And 3 past the decimal point, right, sir, Mr. Roebuck? Even though that makes no sense at all? 3 past the decimal point. Likely AP Central would say round to the nearest whole bacteria, in which case you're allowed to do so. If they don't say that, you got to go 3 past the decimal point. If you go 3 past the decimal point, they did say that, you're still all right. So you might as well. All right. You should go do the last problem now. Have at. Recognize this, Mr. Cross? D equals 1/2 AT squared plus V naught T plus C. More of that in just a moment. Okay, and then if I want to find it at 2, I think it says find it at 2. That's negative 4.92 squared plus 15 times 2 plus 10. Negative 19.6 plus 40 is 20.4 meters. Lost another per second. Okay, so for my physics students or budding physics students, look what we just did. A is A, right? It's constant velocity, then the integral of A dt would be equal to V, which is equal to AT plus initial constant, which is going to be V naught. And the integral of AT plus V naught is equal to my displacement formula, which is going to be equal to 1/2 AT squared plus V naught T plus initial conditions. Well, that's a little different. We don't generally do that, but that's how far you start from the starting line, so you add 3 at the end. Makes sense. Got it, got it?